Are you ready for your active knowledge sharing? Yes?
Yeah!
Great, thank you.
So, okay, I'm going to show you some slides about a project we are working in my department. And this is also a ACE 2020 project. It's from the topic LCE 7 2014. I think it's something like distribution grid and retail market. I think so. And we show this project because we think it has some overlaps with the story project that to some extent we can share some links of information between the projects, so maybe it's worth it to show you how is the project. The objective of the peer-to-peer smartest project is to demonstrate to research how a smarter distribution system can be achieved relying on advanced ICT technologies, regional markets, and new alternative business models. So, with the purpose in mind, the project proposes the use of a peer-to-peer approach for energy trading and grid control mechanisms instead of a centralized one, with the objective to grant a more efficient integration of the demand-side flexibility and an optimal operation of distributed energy resources, but always keeping an eye in the stability of the grid and the quality of security of the supply. So this is a smallest project than the story project. We have a duration of the project about 3 years. In terms of work for this at 528 person months. The total budget of the project is close to approximately 4 million euros, and the contribution of the European Union is approximately 3.5 million euros. So in the consortium there are four countries involved: Spain, United Kingdom, Finland, and Belgium. There are different universities working in the project: the University of Oulu in Finland, the University of Cardiff and the University of Bath in United Kingdom, and the Catholic University of Leuven from Belgium. We have also research centers involved in the project, ATENEA and the Technology Center for Telecommunications of Catalonia. Both of them are from Spain. And we also have different companies involved, mainly energy services companies, ESCOs, like Regenera and Inicom, Instrumentación y Componentes. Both of them are located in Spain. And we also have a DSO, one of the biggest DSOs in Spain, which is Endesa. But in this project, Endesa is taking the role of a kind of aggregator, not the distributed system operator point of view, but from the aggregator of one. So these are the figures, the brief description of the project. And the project, the work, sorry, oops, the other laptop. Out of me as well. So the project is structured, the work is structured in these 7 work packages. We have the classical work packages of project management and dissemination work package. And we also have 4 technical work packages. Each one of them is focusing on different layers or planes in the terms of the electric system power. So we have the work package 4, which is focusing in the peer-to-peer energy markets trading in terms of just energy trading. So the main results here are to try to define innovative market arrangements and advanced optimization techniques to provide an efficient peer-to-peer energy market trading, how to integrate the flexibility of demand of the management of distributed energy resources inside this peer-to-peer energy scheme. We also have our work package 5, which is focusing just in the control of the grid, in this peer-to-peer energy scheme, just to provide an alternative. For example, the main results of this work package 5 are expected to be an alternative peer-to-peer based control paradigm of distribution networks, probabilistic and predictive control functions in order to ease and enable the peer-to-peer based energy trading. And we also have a work package 3, which is focusing in the ICT technologies which are used to enable this energy trading according to this peer-to-peer scheme. And we also have a work package 2, which is focusing in new business models and regional markets. And the main results, the main expected results from these work packages are just to, well, I'm going to explain you a bit deeper this work package later. So, we are mainly, as ATENEA, we are involved in this work package 6. This is the work package for validation purposes. Our objective is to test and validate all the outcomes coming from the technical work packages. So we have just started this year, and we are just defining the preliminary stuff. So we are finishing this work package 6 by the end of the next year, which is the end, in fact, of the project. And this is the target system model. We have a figure. This is a very draft. So there are different layers involved in this peer-to-peer scheme. A trading layer or trading plane, a control layer, also the market layer is represented, and also it's involved the communication layer is not depicted here as a plane, but it's represented by means of these arrows, which in fact, these arrows means the exchange of information. So sadly, this the picture is not very clear here, so but more or less. So we are using different demo sites for the project. We are using our microgrid. I think you guys tomorrow are going to visit the microgrid, so you have the chance to see it and to ask whatever you want. But there are also another demo sites involved in the project. Another one is located in Spain, which is about 2 hours driving from here. We also have in Cardiff another test laboratory to be used in these demonstration purposes. And we also have the energy bill, which is used by the Catholic University of Lebanon, and we use it for demonstration and validation purposes. So yeah, just some slides about the demos. This is the ATENEA Microgrid. It's just some pictures of the microgrid. You will see tomorrow the real deal. So just a few bullet points of our installation. It's a microgrid, which is an alternating current microgrid, low voltage, 400 volts, 50 hertz. It supplies real loads. Part of the wind test laboratory loads are fed by us. But also some of the lighting of the industrial park we are located in are fed by the energy produced in the microgrid. So we have different energy sources, both renewable and non renewable. We have a wide range of energy storage systems, from more classical or more old ones like valve-regulated acid batteries, lead acid, to more advanced ones like vanadium redox flow batteries or ultra caps. And we also have an electric vehicle. It's not a vehicle to grid vehicle, but it's an electric vehicle, okay? And some other electric loads, real loads like electric forklift and so on. And the objective of this installation is to be used as a pilot plant in order to demonstrate the feasibility of this kind of installation in an industrial environment, but also as a test bench for technologies related with microgrids and smart grids, generating technologies, storage technologies, or control strategies for microgrids or whatever, related with microgrids and smart grids. And as a microgrid, it can operate connected to the grid, but also isolated from the grid. So the other one, sorry. No, this is the analytical scheme of the microgrid with some figures about the capacity and the rated power of the different assets of the microgrid. And Okay,
2 minutes to go.
2 minutes. So sorry. So this is. So I'm going to jump to what I think or what we have thought. These are the common links between the projects. In fact, we have work packages which are closely related and are quite similar to the story ones. For example, the work package 3, which is related to communications, it can have some overlaps with your work. It can have, in some extent, some of the inputs of one project can provide information for. I mean, we can exchange information between the results. We also have work packages also focus in business models. So I think the objectives of these work packages are quite similar, but we are focusing in this peer-to-peer scheme, this peer-to-peer paradigm. But you are focused on storage, okay? But some information can be shared. Some methodologies can be. We can share information between us and try to achieve a common ground to share knowledge, in fact. And we also, of course, we have a work package 6, which is for validation purposes. Story as a whole is a demo project, big demo project. But you have a work package 7, which is about the large-scale studies. And we also have some of our objectives in work package 6 is to provide an analysis and overarching recommendations for involved stakeholders and about the upscaling of the proposed peer-to-peer scheme up to regional and national level. So we will use simulation techniques, we will use some tools that you may use some similar tools, so maybe we can share ideas on whatever. And these are the main contacts and responsibles for this peer-to-peer smartest project. I am the responsible of the work package 6 and validation, the validation work package. But the coordinator of the project is Ari Putu, is from Finland, for the University of Oulu. And I have also stated here who are the responsibles. In fact, they are working in the Bridge project in the different work packages, working groups. So we have a guy, Jussi, who is dedicated in this working group 1, ICT, business models is Petri Ahokangas from the University of Oulu. And we also have 2 persons from Endesa involved in the other working groups. Working group 3, social involvement, social public acceptance. In this working group, we are mainly just as a, we are not real users involved in the demo, so we are just learning here. And we are also working in this working group 4, regulatory issues, legal barriers, so this is the person you may contact. So from my side, that's all. So if you have any questions or whatever, I can provide you the emails from these guys or whatever you need.
Great, thank you very much. Thank you very much. Keep that last slide up there. Keep that last slide up there. We can. So, thank you very much for explaining the project. You also mentioned, keep in, don't go off the camera. There we go, there we go. You also mentioned that there might be connections with our work packages 7, with our work package 8, and with our work package 9. But first of all, I'm just turning to Story colleagues. Anything that strikes you about this peer-to-peer project? Any questions that you might have or any clarifications? Can you see some interesting overlaps? Please, please.
P2P is a communication concept, but in the energy grid I
In fact,
talking about not information but real energy.
In fact, it's about energy, but it uses it has to use a communication infrastructure able to provide this fastness we need. I mean, the speed we need or the amount of data we need to share. So we have to trust in a communication infrastructure good enough to perform this energy trade. We are also focusing on this as a peer-to-peer energy trade, but also are some guys in Work Package 5 studying or researching about a peer-to-peer control, for example, of a low voltage microgrid, voltage control in a peer-to-peer way. So we are focusing this peer-to-peer in energy trade, also in grid control techniques, and the communications are the key that enable us to perform this peer-to-peer energy and control. So this is
Excellent. Did you have a no? Andre, do you have? Yes, please.
My question is regarding the balancing model that you're using in peer-to-peer exchange or in market. Because the reason why we have this hierarchical central balancing model is to be able to reconcile the active power balancing between loads and generation. And that's why I'm wondering, this is what also electricity markets are built on, the centralized one. So if you're proposing peer-to-peer markets, how do you deal with the balancing?
so
So the question is, if you're working on peer-to-peer markets, how do you control the balancing?
So there are another working package, work package, which is work package 5, which is dealing exactly with that issues, how to provide the power balance in a peer-to-peer energy market. So you have to take care of the stability of the electric grid. So these guys are in work package 5. They are not dealing only with a peer-to-peer based control for low voltage profiles in the small microgrid. They are also dealing with these issues, how to assure the power balance in, for example, a medium voltage grid in a peer-to-peer environment. This is like, for example, a virtual power plant, economic virtual power plant, and a technical power plant. So you have, for example, you can come up, or for example, I can decide the amount of energy exchange between peers. But this has to be assured by other agent that it is possible to do it. So these control techniques are what the people from Work Package 5 are dealing with.
Thank you.
Excellent. Very good. Any final comments? Yes.
Among the peers or coming to the market or using the market. So the aggregator also has a role, because the microgrid trader can have a bidirectional, a bilateral agreement with the aggregator.
It's a mandatory role or it's an optional?
In fact, we are seeing which are the responsibilities of the aggregator here in this scheme, which is the role that the aggregator has to take over. So this is some of the questions that we are dealing with that in the project. That questions are also raised during the project. So
Very good, thank you. Now, if we have further questions or clarifications, or if we would like, for example, on the business models or on the communications to make that connection, obviously our contact is Raquel, and you can then pass on the various details. We have some names here as well, so we can always get those email addresses. But for now, I would like to say big thank you. Thank you very much for taking your time. Right, moving swiftly on, we have the ever swift Andreas.
Good. I'm happy to present project Increase. Increase is an FP7 project with a budget of about 3.5 million. Have a look at the consortium. It's very international: Austria, Belgium, Greece, Slovenia, Netherlands, but with a diversity of actors. We have research institutions, such as Uneo Research. We have DSOs, TSOs, so district system operators, transmission system operators, technology providers such as ILPRA in Greece, and obviously there's a big overlap between Story and Increase. I'm part of Increase, University of Ljubljana is part of Increase, Elektro Gorenska is part of Increase, so at least three partners are the same and can guarantee a flow of insights and know-how. Have a look at our wonderful webpage. I'm the dissemination manager at Increase, and also here we have a newsletter where I invite you to subscribe. So 2 or 3 times a year you can get Increase news. We have also an Increase movie with a nice little man explaining you in a very simplified version what it's about. But I will explain it in more detail now. You don't need to watch the movie immediately. Also, we have news for different categories, industries, policymakers, researchers. So what's the overall challenge? The overarching aim is, how can Europe meet its 2020 energy and climate targets, or of course the 2030 targets? We know there's a significant decrease. Here we have already a word increase. A significant increase in distributed renewable energy sources. I call it DRES, as technical terminus. But what does it mean for the current electricity market design? Do we need, or will we see new actors, maybe aggregators? What does it mean for the TSOs, and for DSOs who supply the electricity in the low voltage grids? Will they have the same roles in the future? Will they see new business models, or new business models shared with new actors? These are important questions we would want to answer with an increase. So the DSO has to connect DRES, guaranteeing the power quality at low cost and minimal time. And guaranteeing power doesn't only mean if you plug a device in the plug and want to get power. It's more than just power. It's a quality of power to get a stable voltage level and frequency at any point in time. So increase seeks answers for how to actively manage renewable energy sources in low voltage mainly, but also to a certain extent in medium voltage networks. And what could be innovative options, control strategies, business models, possibly also adjustment to the regulatory framework. So how could distributed renewables, for example photovoltaics that you put on your own house, participate in new markets? New markets providing so-called ancillary services. It's system services guaranteeing a high quality of electricity. For example, voltage control, voltage unbalance mitigation, line congestion mitigation, we heard it earlier, or reserve provision. We have different layers of assessment. The physical layer is the houses. It could be your house, for example. You put on PV on your house because you would supply your house yourself with renewable energy. Then we have a middleware layer where the small units are aggregated, and in the lowest level we call it local control. We have to control the many small distributed houses. In the middleware layer we have overlaying control with already a more aggregated control structure, and the top level we call it service layer. It's this layer that is already connected to markets where you can sell products. Individuals cannot sell products, they're too small and there are no market agents. These are the main layers of assessment and increase. So what are we doing specifically? Well, we are investigating regulatory frameworks. Do they allow our new market structures? Or is it impossible at the moment? What about grid code structures? Are they prohibitive? What about the current ancillary market mechanisms? They're different in all 28 European Union countries. Are there similarities? Does it work in some countries better than in other countries? Increase proposes adjustments to facilitate a successful provision of these services. Distributed renewable energy service, but also demand response, that you actively can modify your energy demands, can also provide these services. And the DSO, the distribution system operator, can evolve from a congestion manager to a capacity manager, to a much more active agent. With an increase, we will validate our proposed solutions with a grid model, and we'll investigate all the impacts on DSOs, and this is the reason we have several DSOs in the consortium. The methods applied, also here we have demos in Holland, in Belgium, in Slovenia, Austria. In the demos, particularly, we testing new technical devices to optimize the grids, for example, with a specific kind of inverter optimize the capacity of the grids to absorb renewable electricity. We have a simulation platform to model the grids and see how it could change. We can create what-if scenarios with the modeling. We have specific grid modeling carried out by Andrej Gubina, University of Ljubljana. And here I see already the big overlap to what Andrej is doing also in Story, in the extrapolation work package. And we carry out economic assessments and try to propose new business models. Obviously, also here's a visible overlap. University of Ljubljana and UNEA Research created a special tool to assess the costs and benefits for different actors in the markets. For example, for PV owners, for demand response units, for aggregators, or for the government who wants to reach targets. So for different actors, we can assess the business economic performance, we can assess the environmental effects, but also other co-benefits such as energy security. What will come out? The project ends in December this year. So which results will you see in a couple of months only? The development of a three-phase Y inverter tested in the demos. This is ongoing. Then control strategies. The ICT system, also here I see the overlap to Story. A simulation toolset to validate the control strategies. We have lab tests before we implement our solutions in the demos. And of course, a strong focus on investigation of the markets and regulatory framework. What does need to be changed on European level? Do the different frameworks in the European Union countries need to be harmonized, modified, and able to allow the solutions that we find make sense from economic, social, environmental perspective? Many thanks.
Great, thank you very much. So, Andreas, just repeat for us again, where do you see the main opportunities for overlap or cooperation with Story?
As I mentioned earlier, where three partners are the same, and this, of course, is a guarantee of information flow. But of course, developing business models, proposing changes to the regulatory framework for new innovative market models. Of course, grid modeling that Andrej does. I think there's some overlaps also on what we're doing in the demos. Of course, the questions are a bit different, but in Slovenia, I think it's almost the same demo site, Mayan.
Yes, one of the demo
Yes.
sites is the same. We're using the same control technologies.
Yes.
Yes.
Okay.
So modeling business cases and regulatory framework.
Okay, excellent. Now, we're going to go over to you for questions again. If I could ask, particularly if you're sitting at the back, to almost shout when you ask your question so that it can be picked up on this microphone, which is helpfully pointing in the wrong direction. I don't want to change the microphone around. I will try and repeat the question if I understand it. Andrej.
Clarification. So thank you very much for a very nice presentation. As clarification, in increase, we don't deal with storage at all.
This is the case, yeah.
So adding storage to any control ideas, to any control strategies, and any grid architectures that we may have done in increase or used in increase, this is where Story actually builds on the results coming from increase.
Excellent. So adding Story into the mix can help us build on that within storage. Can help us build within Story. But for people who are not involved in increase, any questions? Do you see some overlaps? Do you see some linkages? Please.
To what extent is increase building on a conventional model of organizing the grid, in the sense that you have schedulers, planners, you're relying on statistical forecasts to make the deals, and rely on control to compensate for all the misforecasting, or are you, say, allowing users to communicate through other means how they're going to load the net or not.
You
Andre,
could just repeat the question to the microphone and then
Andre,
give your answer.
may I pass the question to you as a grid modeler?
Could you just repeat the question?
Paul, you ask about statistical forecasts.
Yeah.
To what extent they can be modified, or to what extent?
The classical grid is actually planned based on statistical forecasts,
Mhm.
and controls have to take care of all the deviations because you have no impact on your users. Now with smart grid, we have users,
Mhm.
and they can tell you upfront how they're going to behave. They can tell this through markets, but they can also tell it otherwise. In the sense, probably you can tell it better otherwise if they're not constrained to that. To what extent is increase open to these new ideas, or is it just looking at the conventional control?
Have a quick go at answering the question, because we'll not hear Andre from all the way back there.
Andre, I think only you can answer it because you modeled this.
Andre, would you like to come up very quickly?
So the question is whether in increased project we rely on traditional statistical forecasting methods of the behavior of the actors instead of using the maybe additional information that would come from these smart grid users. Of course, we're open to all kinds of additional information that could be used. However, given our discussion with the consumers and the social scientists modeling this behavior, I would say that the consumers don't have a clue how they would react to any of changes and additional new ideas coming up on the market. So us relying on them telling us how they're going to behave is an engineer's dream. And because we had this discussion with the social scientists and we asked them, can you tell us how the consumers are going to react? Because then we can really make solutions for them. And you're the social scientist, you should know. And they told us we have no idea because the consumers themselves don't know. So we have to come up with the marketing approach, giving them catalog of possible behavior of theirs, and also pros and cons, costs and benefits, and then they can choose.
I'm afraid your social scientists are not aware of possibilities in the sense that machine learning probably does a better job than themselves to get these predictions. And also from the video project, we learned that if you ask them to make available their flexibility, which you have anyway, give them a minimal fee for that, and then use the flexibility yourself as you see fit, are two ways where you can improve on the current, say, just go for statistics.
Indeed, the question is answered.
Yeah.
I take your word for it, and we can discuss offline about this. Thank you.
Very good.
Any other questions?
Well, ladies and gentlemen, I think we've probably also run out of time, which we need to go now. But thank you all very much. Thank you, Andreas,
Thanks
as well.
for inviting me.
If you have a project that you think is relevant for Story and that people here in this room should know about, then please do contact Stefan or myself. We will be doing this on a regular basis and putting these videos up, but it is important that we're aware of what else is going on, particularly if projects are coming to an end, so that we can use them and build on them to make Story even more successful. So thank you all very much.